I've given you all of these ways to untie the knots. If you still got issues with ownership and you still want to use threads, look into lock-free structures. In particular, I love DashMap and DashSet, which is a hash map that handles all of the locking internally, uses some very, very clever code for switching out tree nodes, making it very fast. You can use it pretty much as you need to throughout a big threaded context. You can deadlock it. It's really hard to do. The Crossbeam crate gives you pretty much all of the opt-outs that you might ever need if you are running into something really complicated. Obviously, I don't have time to write something hugely complicated in a 1-hour webinar, but AtomicCell gives you a thread-safe mutable access to a variable. You just have to be careful with it. There's a thread-safe work queue, which is what Rayon uses for its work stealing system. There's a skip list, which gives you a whole binary tree that you can access concurrently between threads without needing to worry about locking. If you dig in deeper, you can emulate Go style wait groups. Got those. You can even use its epoch feature to add a full garbage collector to part of your program, if that's what you want to do. Okay, so to summarize the memory section, Rust retains data race safety throughout your program, no matter how complicated. Moving lets you transfer ownership between parts of your program. Borrowing becomes harder in the threaded world, but it becomes harder for a good reason, because you really don't want to have a pointer to something that no longer exists. That's been the cause of so many bugs in the last few decades. Rust eliminates that class of bug. You're trading a bit of complexity on your time, the programmer, in return for not accidentally leaking nuclear codes when you write some system for a missile. Arc gives you a reference counted system for those times that you need to opt out. Ownership isn't cut and dried anymore. Interior mutability lets you hide all of this complexity so that the people who are using the code that you've written don't have to worry about it. It also lets you divide and conquer, so you can divide parts of your data up, operate on it independently, not have to serialize your whole thing through one mutex. And drop is RAII from C++, makes sure that things get cleaned up. One last section, I am running very slightly late, for which I apologize. Talking between threads. Channels. Channel in 1989, Van Jacobson came up with the idea of a wait-free structure for pushing data between two threads. They're not unique to Rust. The Linux kernel has a ton of them, including 5 or 6 different implementations. The Go language uses channels everywhere. On C++, Boost ASIO uses channels. Java's had them since SE8. So a channel is basically a sender and a receiver. You submit data to the channel. The receiver in a different thread can then receive the data at some point in the future. Before channels existed, it was pretty common to see spaghetti code where you have global shared variables representing, hey, I'm quitting now, or hey, thread 2, do this. And thread 2 would at some point read, hey, I'm quitting, hey, do this. And it works. It doesn't scale. You wind up with a program that looks like somebody took spaghetti and threw it at the wall. And so avoid confusion. Channels are the best way to be sending data between threads. Very quick demo. MPSC, multi-producer, single consumer. So as many senders as you want, a single receiver. We create a channel, create 10 threads. You can clone the transmitter into as much as you want. It uses Arc, so clone is effectively a free operation designed to be cloned. Each of these threads can send numbers into the channel. We're calling RxReceive, the receiver, to receive data from the channel. And you'll notice that we're unwrapping. Most of the time you would check for an error. Unlike some other languages, the channels themselves also use RAII. So if there are no transmitters remaining, or the receiver has gone away, the channel will close, and attempts to send or receive into it will return you an error message instead of crashing. So that's the drop trait at work. Channels aren't just for numbers. You can send almost anything through a channel. So here I'm sending a command, double it, and one shot is another type of channel. It's optimized for sending exactly one message and never sending more. Send the thread. We send our enum over there, double it, and we actually then use the other channel, the one shot, to send the answer back. So in practice, we make our one-shot channel. On our main channel here, we send the command, give it the way to reply to us, receive the reply. And this is something that you will see all the time in async code, quite often in threaded code. You can even pass function pointers if you want to, and that's how a lot of thread pool systems like Rayon work. This code here is almost the basis of a simple non-work stealing version of Rayon. It's also, if you're into computer history, pretty close to how object-oriented programs are expected to work initially, message passing between discrete systems. Congratulations, we implemented the actor model in 20 lines of code. Couple of things to note: you don't have to block. You can use try receive, which will instantly return that I don't have any messages for you. If you have multiple potential sources of data, you can try receive on them. This is particularly useful if you've got a channel whose main purpose is to tell a thread to quit, because killing a thread from the outside is painful. There are also timeout options available. If you need to start multiplexing lots of channels into one thread, you need the Crossbeam crate. It implements a select macro, just like you see in async all the time. Allows you to receive on as many channels as you want. First one to send you data, it processes that one. This can be fantastic when you have heavy calculation threads that are each spitting out answers, transmitting them into one or two threads whose purpose is to transmit those answers off to another system. Crossbeam is well worth a look. You'll see it's in most of the really big Rust programs out there now. Rust has your back with safety. Like I said, it will close the channel for you. You still want to be careful. If you're selecting between lots of channels and they're all busy, fairness is not guaranteed. I get asked that a lot. So if you have two channels, both of which are blasting out data at a high rate, it's not guaranteed that select will fair share between the ones that are coming in. There's also a concept of channel bounding. The channels that I showed you here are unbounded. So if nothing's receiving them, they will keep growing and growing and growing and growing until you run out of memory and the out of memory checker kills your program. There's also a bounded channel option, which just lets you specify a maximum size. And then when you send to the channel, normally it doesn't block, it sends immediately. Sending to a channel that's full will block and wait until there's room in the channel. So it won't fail, it'll just slow your program down. So this can be used to apply back pressure if you want to make your program more self-pacing.